Hello, this is Tyler Moore from the University of Tulsa. Today we'll be talking about cost-benefit analysis. Here's an outline of what we'll cover in the following three videos. First, in this video, we'll talk about an overview of cost-benefit analysis and how it relates to the security investment metrics we've discussed already in the course. In subsequent videos, we'll first talk about a couple of case studies where we apply the cost-benefit analysis techniques, and then third, we'll cover how to deal with uncertainties in the calculations for the measures. So as a reminder here, the metrics that we've talked about in the course so far. So we have this sort of first group of metrics which have to do with how do you quantify security benefits, essentially computing expected loss and expected net benefit, which is expected loss minus the cost of security investment. And then there are a couple of high-level metrics we also discussed: return on security investment and net present value and internal rate of return. So these metrics allow us to answer some questions but not others. So if we want to invest in security, we say yes, we do if our expected net benefit is positive. Should we invest in defense A or B? Well, we choose the one with the higher return on investment or net present value. How much should we invest? Well, we can look at one of the security investment models we previously discussed, such as the Gordon-Loeb model, which will say investing until the marginal cost of added security is equal to the marginal benefit. Then we have another question: is security investment cost effective? Well, the answer we've heard so far is that yes, if you have a positive expected net benefit of security. But the cost-benefit approach says, well, yeah, it probably is, so long as the minimum probability of attack required to break even is high enough. Okay, so what does that mean? Well, we'll unpack that today. So cost-benefit analysis is widely used in public policy to justify government expenditures, and it's in fact quite similar in design to the security metrics we presented earlier, expected net benefit. The emphasis is placed on making first your best effort estimates of figures like the cost of insecurity, which we know as the ALE0, the cost of a security countermeasure, which we know as C, the probability of attack, which we know as P0, and then something else called the risk reduction, R, which we haven't seen before, but isn't all that different from what we've seen. So the risk reduction can be thought of as the sort of fractional change in the probability of attack after a security investment. So it's specified as P0 minus PS over P0. And as I've said, under cost-benefit analysis methods, security investment would be considered cost-effective if expected net benefit is positive. And whenever you compute cost-benefit analysis, what they do is they take the figures we've talked about above and use them as evidence to decide whether or not you should adopt a countermeasure based upon if the benefit can justify itself. And one of the sort of key innovations, I guess, of the cost-benefit approach is that it accepts that there can be uncertainty over the calculations of these figures, and so it handles that by examining a range of values in order to see what would be a plausible break-even point. So now we've introduced our new variable R for risk reduction. We can translate that back into our existing INBIS metrics, and so in particular for the INBIS metrics that rely on the Bernoulli loss assumption for P0 and the improved probability of security investment of PS, we can just do a very simple trick of algebra, and so we know that expected net benefit is P0 minus PS times your loss minus C. Well, you can with this trick, you can say, well, it's actually that's equivalent to P0 times P0 minus S over P0, which is exactly R. So this is an alternative specification of the INBIS metric if what you're interested in is the risk reduction fraction that's available. We're also going to introduce another sort of wrinkle to our metrics. Because up to now we've only considered a single financial loss lambda that would be associated with an attack. Either you have that loss or not. But in fact, losses can take a lot of forms, and each has its own magnitude and probability of occurrence. So, let's say there's an earthquake. Well, first of all, that there could be a probability of damage to a building, which would have a certain cost associated with it, whereas and that probability and cost could be different for different buildings based upon their own characteristics of earthquake resistance. So we can sort of disaggregate the loss function into these constituent parts as follows here. So we're basically, all we're doing is we're taking this single loss lambda and converting it to a sum over n component losses, and each one is computed by just giving the expected loss in each case. So it's the probability that a particular loss is going to occur given that that an attack happens times that loss value. So you add it up for all the types and you get an aggregated loss. So why introduce this sort of wrinkle to our formula now? Well, with cost-benefit analysis, we're very careful to try to systematically estimate things like the loss, and so decomposing into parts is one way to do that. So what's the overall task for doing cost-benefit analysis? Well, first of all, we want to estimate, as to the best of our abilities, what P0 is. Again, this is the probability that there will be this adverse event, in our case, an attack, using all the available data we have. So sort of the steady state probability of attack. We then enumerate the loss types, estimate their cost and conditional probability as described in that formula. Then we can estimate, or sometimes take as input, the security cost C, so how much this is going to cost us, and also the risk reduction rate we get from the security investment. And in the next video, we will put these new measures to the test for two case studies that are covered in the reading. One is considering mitigations to terrorist attacks targeting highway bridges, and a second is looking at sewer overflows at wastewater facilities. To learn more about that, continue on in the next video.